Much of the data that we collect or are interested in is going to be categorical or qualitative by nature. So when we're thinking about qualitative or categorical data, we're really thinking about data that describe sort of the categories of something, that describe the text of something, that are non-numerical by nature. And this non-numeric data is going to be very interesting for asking a whole suite of different questions. Many of the questions that we're going to care about are going to be driven primarily by qualitative considerations. The challenge for us is that in order to conduct statistical inference, whether that's the thought of estimation or the thought of hypothesis testing or somewhere in between, we need numeric information. Hypothesis testing, statistical inference more broadly, relies entirely on the numerical information within a data set. And as a result, there's this tension where if we collect qualitative data, we might be asking ourselves, well, how can we still conduct statistical inference? How can we still draw data-driven conclusions from these data? So when considering qualitative information, our standard techniques for statistical inference cannot be directly applied. What we need to do here is actually transform the information to being quantitative. And so how do we go about doing that? Well, the primary tools that we have for this are going to be frequency distributions and contingency tables. So a frequency distribution is going to represent the summary of observations of any qualitative variable. So the idea is that we take a look at all of the possible values that this qualitative variable could take on, and then we summarize how often did we observe each of those different values within our data set. So it's going to contain both the possible values that could be taken on by this random variable, as well as all of the counts that we actually happen to observe in our data set. So we go through, we enumerate the possible values, the possible categories, the possible options for this variable that we care about, and then we count up in our data set how many times did we see the first option, how many times did we see the second option, and so forth. Now this can be applied to quantitative variables as well, the frequency distribution that is. So if we have a quantitative variable, if it's discrete, then perhaps we already have it in two different categories, right? So how many number ones did we observe? How many number twos did we observe? And so forth. If it's a continuous variable, we can do what is called binning and still come up with the frequency distribution here. And the idea here is that instead of thinking about single values, we think about ranges of values. So how many times did we observe something between 0 and 1? How many times did we observe something between 1 and 2? And so forth. And so in all of these cases, we can think about the frequency distribution, but it's going to be of primary importance to us if we're thinking about qualitative information, because if we have continuous or discrete information, there are going to be other numerical summaries for this. With qualitative information, the frequency distribution really is the key numerical summary. We can think about what we're doing here as essentially forming a histogram or a bar plot. We are going through, we're looking at the possible range of values, and then we're counting up in our data set how many times did each of those values, how many times was each of those values observed. With a frequency distribution, we're thinking about a single variable. Now, if we start to think about what happens with more than one qualitative factor, we can start to think about this as being summarized through a contingency table. So a contingency table takes two or more qualitative variables in the same manner, and it expresses their joint frequency distribution. So we think about how many times was the variable A taking on its first option with variable B taking on its first option. How many times was the variable A taking on its first option when variable B had its second option, and so forth. So we're listing all of the possible joint combinations of these two variables, as well as in our data set, how many times did we observe individuals who fit at those joint intersections. So it's going to give both the count and the combination for the two or more factors. Now, typically with contingency tables, we're thinking about it being two factors. In theory, you could represent this as more than two. However, it's going to be most common to represent this as being the summary for two different variables here. From the contingency table, we can actually work out the individual frequency distributions for both of the factors. And typically, these are going to be immediately summarized for us in the margins of the contingency table. So in the margins, we're going to have the totals for our rows and for our columns, and those are going to represent the frequency distributions for each of the underlying variables. So both frequency distributions and contingency tables are going to summarize qualitative data in a quantitative manner. And what this is going to permit us to do is actually conduct statistical inference using these frequency tables or frequency distributions or contingency tables. So taking a look at an example here, we have a subscription-based streaming service that is collecting data in an attempt to understand if there's a relationship between their subscription tier, so they have a basic, a standard, or a premium, and whether or not they churn. So customer churn is a big thing in the business world. Are they unsubscribing from the service each month? And so what we have here is we have our data, right? So we have our subscription tiers listed down through our first column here, right? So we have our basic, our standard, our premium, and then we have whether they churned yes or no. Okay, and so those are going to give these two columns worth of data. So the first thing to note is that if we wanted to think about just our basic customers, right, we're thinking about just this first row here, just our standard customers, that's our second row, and just our premium customers, that's our third row. If we want to think about, well, which customers are churning and which customers are not churning, the ones in this first column here are the ones that churn, and the ones in this second column are the ones that don't churn, okay? And so then in particular, what we're saying is that over this period, there were 150 basic customers who churned, and there were 350 basic customers who did not churn. There were 100 standard customers who churned and 600 standard customers who did not churn. There were 50 premium customers who churned and 750 who did not. Okay, and so that's how we're reading this. So this is giving us our joint breakdown of both the individual the subscriptions and whether or not each individual churned. And then we can think about, well, what's happening with our margins, right? So we have our totals for our rows and our totals for our columns here, right? So this 500, this is this 150 plus 350, and that tells us the total number of our basic subscribers. The 700, which is the 100 plus 600, tells us the total number of the standard subscribers, and this 800 is telling us the total number of premium subscribers. Similarly, this 300 is going to tell us the total number of customers who are churning, and this 1700 is this total who did not churn. In both cases, we end up with a total of 2,000 customers overall. Right, and so then we can think about either this margin as being the frequency distribution for your subscription tier, or we can think about this margin down here as being the frequency distribution for whether they churned or not. Right? So we have a lot of data that are summarized within this table here, and it's summarized in a fairly compact manner. Right? So we can pull out the frequency distributions for our subscription tier as being 500, 700, or 800 for basic, standard, and premium. The frequency distribution for the customer churn is summarized as 300 versus 1700 for churned versus non-churned. Right. If we combine all of this together, we get this contingency table here. Now, most qualitative information in these data are going to be summarized within this table. Right? Most of the information that we're going to be interested in is going to be about counting, well, how many basic subscribers do we have, or how many standard subscribers do we have that actually churned this month, right? It's going to be these types of questions. And so most of the information that we care about is actually going to be summarized within this table. So how do we conduct statistical inference for qualitative data then? Well, for qualitative data, what we can do is we can compare the frequency distribution, or our contingency table, to whatever we expect based on what it is that we're interested in. So we can ask whether the data appear to contradict some particular viewpoint that we hold, or whether they seem to support that viewpoint, right? So do they follow some specified underlying distribution, for instance? Perhaps we expect that the data should be evenly distributed across all of the categories. Does that appear to actually be the case? Right? We can ask to see whether two different variables appear to be dependent on each other or not. Right? So are they actually dependent? Is the type of subscription that they have actually dependent on whether they churned or not? Right? Are these independent or are they dependent? Right? So what we're going to be doing in order to test our hypotheses related to qualitative information is we're going to come up with whatever our hypothesis is, right? We are going to hypothesize that these factors are independent of each other. We're going to hypothesize that they follow some set distribution. We're going to hypothesize that these two different populations actually have the same frequency distribution, right? We're going to come up with some hypothesis, and we're going to turn that hypothesis into an expected contingency table or an expected frequency distribution, right? So we're going to ask ourselves, if what we think here is true, if what we're hypothesizing is actually true, what should the contingency table look like? What should the frequency distribution look like? And then we can take what we've actually observed and compare it to those expectations. And by doing that, we're going to be able to derive hypothesis tests for qualitative data. So frequency distributions and contingency tables both provide quantitative summaries of qualitative data. The summaries can then be compared to expectations in order for us to conduct statistical inference. And so at the core of doing statistical inference for qualitative data are going to be the contingency tables and the frequency distributions of those data.